We are now going to calculate all the same characteristics of these quadratics as we did with our original expression when we factorised it into two brackets. The only one we are not going to find is the roots of the parabola, and that's because in this form it would be incredibly difficult. I recommend that if you have a question asking for the roots, you do your double brackets. But then you may ask, well, what's the point of even talking about this form? Because clearly I already have a method that works. I don't think it's going to be valuable. The other method relied on you finding the roots, because you had to find the roots to find the axis of symmetry, to find your turning point. This method allows you to find your turning point and your axis of symmetry within seconds. The bit you have to practice is factorising it into this form first. But let's look at how we can find each of these things using our completed square form. So we have f of x equals x plus 3 all squared minus 12. Now remember the rule for your y-intercept. Your y-intercept happens when x equals 0. So the method is the same, and I said before, it doesn't matter what form, it could be pre-factorised. So long as you substitute x is 0, you will get the same answer for your y-intercept. So the 0 is going to disappear, and we're left with 3 squared take away 12, 9 take away 12, minus 3. So here we now know that on this parabola, we would be crossing at the coordinate 0, minus 3. And remember, if you're asked for the y-intercept, you have to state it as a coordinate. If you're asked to sketch, it's enough for it to be on the graph. Let us look at our second example. Again, f of x equals x minus 2 all squared minus 2. But to get the y-intercept, we are going to make that f of 0. So we've got 0 take away 2 all squared minus 2. A negative times a negative will give you positive 4. Take away 2, and the y-intercept is going to be at 0, 2. If I was drawing a sketch of this, I would mark my 2 on the sketch. Process is identical. There's no real advantage to which way you find the y-intercept. You could have even, if all you're asked for is the y-intercept, used the equation at the start there. And if you sub 0 in, you're left with just the bits at the end. And once again, you can see minus 3 matches the end of the equation. 2 matches the end of the equation. It does not match, and I am emphasising this, your completed square form. So be wary of making that assumption. I promised you at the start of this video that once you had your function in its completed square form, you would be able to find the turning point and the axis of symmetry within seconds. I would like to remind you that these two things are hand in hand, because your axis of symmetry will be x equals a value, but that value is your x coordinate in your turning point. Okay? So once you find your turning point, you have your axis of symmetry, and vice versa to an extent. What is your turning point? Well, most of the parabolas we deal with, you'll have a minimum turning point because your x squared is going to be positive. Because your x squared is positive, we have a minimum. That means we are looking at how we can make this function as small as it will ever be. Okay, we want this to be the smallest or most negative it can possibly be. But the thing that's stopping us from just making x incredibly negative is that squared. Because remember, if you square a negative number, it's positive. If you square a positive number, it's positive. If this bracket is anything other than 0, it will be making your quadratic larger, the value larger. So to combat that, we just need to get rid of it. So what value of x do we have to have for that bracket to disappear? Well, it's going to be the flip of positive 3. It's going to be negative 3. So we end up with x equals minus 3. Minus 3 plus 3 equals 0. That disappears. And you will be left with minus 12. So when x is minus 3, you are left with just 12. And that tells you your turning point. Your turning point is minus 3 for the x and minus 12 for the y. If you were asked for your axis of symmetry, you would be able to say x equals minus 3. You would mark those on your graph. So your turning point is at 1, 2, 3. And because you get to make the rules, you're going to have to extend your graph a little bit. And minus 12 will probably be somewhere down around there. You will not get asked for your roots. So you're just connecting those in a symmetrical graph as you can. Okay. And you might want to neaten it up, but there we go. Minus 3, 12, minus 12. Okay, let's look at the second example because that is quite a lot to take on board. Again, this x squared, when it comes out, it is going to be positive. So we are looking for a minimum turning point. We are looking for the value that will make this function as small as it can ever be. The only way that will work is if our bracket equals 0, because otherwise it will be a positive thing getting added on. So x take away 2 equals 0. X would have to be 2. Okay? And that's you find your axis of symmetry at that point. So axis is x equals 2. But let us get our function. So we know that when x is 2, this will be the value of our y value. The bracket's going to disappear. You're going to be left with minus 2. So your turning point, TP, is 2 minus 2. You look at your graph and you mark it in 1, 2, 1, 2, positive, down to negative. And again, you're just having to do a reasonable estimate of a parabola, showing where you're crossing, and most importantly, if you've done a bad job at it, doing your best to make it symmetrical. You mark your point, and that is you having sketched, using the completed square form, 2 parabolas.